Welcome everybody to our talk at the QoS Fest, and what we want to complex application in the Kubernetes cloud. So this is a common project of immer, which are our customers, and Endocode. So we did some of the consulting there, and we will show you how you can put a real large application into a Kubernetes cloud. Who am I? So I'm Thomas. We are from Endocode, a company which is very closely located to here, so we can walk to our office. And what we do normally is we do technology consulting, DevOps projects, software development, and things like these. And this is the things we want to talk about. First thing is I will hand over to Jannis, who gives you an impression what immer is, what kind of application. Then we show you how to start to convert a complex application into a Kubernetes application. Talk about the challenges of migration, and yeah, then we will declare success and explain you what's missing. So please, let's change to immer.
Okay. Hi, I'm Jannis. Thank you for joining us here today. We were thinking about how to best explain to you what we went through in the last about half a year, well, 9 months at immer, and how we worked with Kubernetes. There is a lot of technical stuff to it, but I also thought it would be kind of interesting if I explained to you how we got there, like how did we get to know Kubernetes, what problems did we have that was solved, what problems do we still have that were not solved yet, but might be solved in the future. So I'm going to give you a short journey of Kubernetes at immer, so that's not a mistake there. That's actually how you spell our name. You can make fun of it later today, but right now, just try to read it as it is. So my name is Jannis. I work as the IT operations, infrastructure, and security lead at immer. Immer is a subsidiary of Deutsche Telekom, so we have a big mothership that supports us, and I will also go into some of the details, what that means for us as a company. I have a background in software architecture, SOAs, building private cloud infrastructure for Deutsche Telekom, and a very strong interest in distributed systems. Also a father of two, and which is maybe important for you. There's a lot of esports going on in Berlin, so if you're a fan of esports, it's the right place to be. About immer. So at immer, we want to make your communication to be as much as possible and easy as possible in the background of your head, right? You don't want to think about, right, I'm going to try and reach Tom, and Tom is on WhatsApp. Okay, but I want to talk to Mary too, and she's on, well, was that Skype or was that Threema? And there's so many messaging and voice applications that we and coming back to our mothership being Deutsche Telekom, there's so many things wrong in the way we distribute our communication today. So we at immer try to solve that problem by taking away, or not taking away, making that pain go away of your communication ID that's tied to your number. And if you would be a normal customer, I would tell you put it into the cloud, but that wouldn't work with you guys. So we basically let you communicate across devices with your phone number, that's your current identity, and abstract from that. So you can log into my device, you can log in the web browser, you can log in your own device. It doesn't matter. You always have your communication with you at all times. We'll be launching an invite beta in the summer, and we'll be launching in European countries at the end of the year, and of course to the general public. So it's not really necessary to explain all the details of how we do and what we do, but it's more interesting for you probably how we got into contact with Kubernetes. So the first contact was for me in Silicon Valley in May 2015, and was working with the talented team at Metaswitch for Project Calico. It was pre 1.0 of Kubernetes, and I guess I would call it alpha of Calico. And the initial idea was to use, for my job back then, Kubernetes as a way to distribute container clusters across edges of a telecommunication network. I'm not going to go into detail what that means in general, but if you want to talk about that later, I'll be happy to. And I also attended a Google workshop in San Francisco, which really helped me. And so I came back, and then my boss offered me an operations lead at the company that was to be founded. Last year, we were founded, I think, in July. And it was an ongoing project already, transitioning from project to actual company phase. And they had microservices. Yay! And every service even has its own database. That's really what we like to see. And so they told me, you can build up a team and start preparing that for production. Okay. So I went ahead and talked to the developers and asked them about like how we're going to scale. We're running one service per VM on a private OpenStack cloud. And I didn't really get an answer. So I guess I thought this is fine, yeah. We're going to try to manage that somehow. And I thought back at what we did with Kubernetes, not from a network perspective, but from an actual application perspective. And we wanted to use some of that knowledge that went into such a really cool distributed system to alleviate some of the problems we will definitely have or would have had if it weren't for Kubernetes. So we went down and consolidated to 2 databases in general. So we took out the persistence layer from the microservices. We got scaling basically for free with Kubernetes. Yeah, I know it's not free because you have to adjust the application sometimes a little bit. But the architecture behind the services that we had was actually pretty good in general. Just the scaling part wasn't really there yet. So we needed a way to instantiate, replicate, and also monitor the different instances of the services. So to give you a number, we have around 20 services running in terms of distinct services, and then depending on the load, times X each service. And we have a storage backend, 2 storage backends, one based on CouchDB and one on Postgres. And so another thing that we needed solving was the service discovery. We looked at different solutions. Actually, what I found very interesting is that the SkyDNS approach of Kubernetes, or that's connected to Kubernetes, works very well for our scenario. So it's a simple service, but it's very powerful. And there were other features that we did not use yet, but we will use in the future. And this is just something to look forward to, like canary deployments, healing, and later on auto-scaling. We are working heavily with secrets and config maps. And that's overall some really, really smart people spend a lot of time on the system, and it shows because you can reuse a lot of that for your own systems and not worry about how to build the distributed container cluster. Great. So yeah, Kubernetes is not everything. So you still need a lot of things around it. I'm not going to go into every single box in here. It's just that I want to show you a little bit what we identified as gaps, but also to make to give huge thanks to the community, because some of the things we encountered on our way to production is that other people encountered them as well and already fixed them for us. So that's pretty good. For instance, client-driven updates. It used to be that you trigger a rolling update from your client station and that would move with the solved with deployments. So we're using external load balancing on AWS for various reasons, and I'm really looking forward to see how Ingress works in the future. And we might even transition to that. I have to test it first. I haven't had the chance yet. We're currently too afraid to run our normal databases in the container cluster, not because the container cluster can't handle it, but our concepts for the databases are not distinct enough to run in that system yet. So we're doing the classical approach to do actual just VM-based and currently an RDS cluster. Also, when we started off, we were working heavily with Chef automation to deploy, configure, and manage all of our services. So we need a smart way to transition between that development phase that's still classic VM deployment with Chef in different stages, so development, QA, like a demo trial environment, and then we go into live. So there's still a gap, and we didn't want to disturb the development workflow, so we started from the bottom, from the top to build up a stable cluster, and we will move that cluster down the testing and QA chain for the developers to eventually have the same environment as live. But that was too much at the same time. And so there's still a lot of things that we need solving. So I'm going to try if this works. Yeah. So one of the things we really need to take care of, because we are a subsidiary of a large German telecommunication infrastructure provider, is security and security management. So one of the things that they told us, like, all right, if you really have to, you can run on Amazon, but you have to make sure that Amazon does not have access to your keys, like to your actual encryption keys. So we use a key management system that's in a different data center and connect that to the Amazon cloud. So we had to solve that part. Probably most of you won't have that problem, hopefully. But we still needed a lot of things, and it helped us a lot to have a small team and work with all the services that AWS gives us. So we heavily make use of S3, the overall DNS management via Route 53. And I told you earlier that I had a really good workshop with Google, and they have awesome infrastructure. So if they can just put that infrastructure into Germany, then I can really use it, because our compliance said you're not allowed to move your data outside of Germany. So if there's anyone from Google here, please build a data center in Germany. Yeah, so that's it from my journey part. So Thomas will give you some more insights on the actual technical stuff. And a big thank you to him and the whole Endocode team who helped us bootstrap our Kubernetes cluster from almost nothing. And yeah, it wasn't really my work that was done on the technical part, but them. Thank you.
Okay. Yeah, this is kind of amazing. So you have Google infrastructure and an Amazon cloud for a telecom project. So everything is growing together, and yeah. What have been the actual challenges? So this was quite an interesting project, because this was one of our first projects in this area. And starting point, I always want to show is the architecture. Normally, you don't, even in a startup project, after a few months, you don't start on a green field. There is already technical debt. After 6 months, you have technical debt, and everybody knows that it takes much longer to remove technical debt than to build it. But I think the challenge was interesting, and yeah, the entire environment was, so the mindset was there, but the environment was not really made for microservices. So this is the first picture, a kind of abstract one, which I always talk about if I recommend how to go into a Kubernetes cloud. So first thing you have to do is to align your applications for the Kubernetes pods. And this means you have to distinguish between your kettle applications. Kettle is the term if you can eat it for breakfast or lunch and throw it away. And your pets. Your pets are normally the more interesting things to you because this is the content of your databases. So the kettle lives in the medium layers, and the databases normally contains your files, your SQL databases, your NoSQL databases, your messaging systems. And the kettle is the stateless part of the application. So the web application, the notification services, user profiles, logins, the web portal itself, even the intermediate caching layer can be considered as kettle because it can be reconstructed anytime. So there is no need to save the data in a Redis cluster. You only have to care about the SQL databases. And this is something you should have in mind. If you start developing for Kubernetes, you have to do the separate. By the way, not only for Kubernetes, if you do anything with DevOps, you have to do it anyway. Separating between stateless and persistent parts of your application is essential for any DevOps job. So this is nothing new, even if we don't do real DevOps at the moment, but this is a precondition to do DevOps, that you exactly know what you are doing, and then you have to protect the database. The databases are special because nearly every database has a different replication protocol. So if you have to replicate MySQL, it's completely different than Postgres, and this is completely different than, for example, MongoDB. And at the moment, you can do everything like this, and you can hope to do this in your cloud providers' services. So Amazon and Google offer a lot of things which are easy to use. If you don't need a very special database, you will be quite happy using your cloud provider's database, and this means your persistent layer is delegated to the cloud provider services, which relieves a lot of pain from you, because setting up databases in a reliable way in the cloud means that you have to understand the replication protocols and things like this, and you do this kind of effort for every database. If you have a very special requirement, we have some experiences with databases in clouds, but normally I would like you to avoid this pain and simply use what you do. There is no need to do your own version of MySQL in the cloud. There are a lot of services there. Okay, and already this was a simple and clean picture, and this is a reality. So it's a little bit more complicated, but shows you here again is the persistent layer, and on top is something which you expose to the public. Another thing, what you also should use is your cloud provider's way of doing load balancing and firewalling, because this is another pain. I don't know who of you ever had to configure an F5 load balancer or something like this. This is also a lot of work in a DevOps team, which can be completely eliminated in this approach, and you simply use the Amazon or Google load balancers. And yeah, this is taking away, I don't know how many percentage of the daily DevOps work, but it's another big relief from work you don't want to do for your application. And then you can focus on the application, and this means that you have to make all the applications in the cloud aware of that they are running in a Kubernetes cluster. If you look into the internet, you see a lot of Docker files which have been derived from virtual machines. So we also in the beginning started to write real bad examples of Docker services. I've written an example how to run an entire Hadoop cluster in a Docker file, which is okay for development, but this is completely wrong for production. In a production environment, you definitely should do the approach of Kubernetes where you put into every pod a bunch of containers, and in every container there should run only one process. This is more or less a contract you have to give to the outside. Your microservice is not a real microservice in a Kubernetes term if you run different processes and the outside of the embedding Kubernetes system cannot detect if your process is running or not. So the only way of doing this is run one process per container, attach it to standard out, or if you have more sophisticated logging requirements, use another logging service, and that's what you need to do. And then you can go into existing heterogeneous environments, and then it doesn't matter. If you keep this contract, one process per container, and every container dies if the main process dies, then you can have the entire variety of programming language. It doesn't matter if you do Java, Python, Ruby, Node.js. What inside the container is, besides this contract, is completely, it doesn't matter for your application. You can even run databases in your container if you attach it to local storage and get the replication right. But then you have to keep in mind that you have that also the database process have to give you back this contract of a microservice. Okay, Jannis already mentioned we have kind of semi-automated deployment here, and yeah, what do you have to do in a migration process? Is you normally find a way of running all these things in a virtual machine, in an operation system instance, and then you turn it into microservices and pods. And the interesting thing is a pod is an entity in terms of Kubernetes, which means it's created together, it's running together on the same node, it's terminating together. It has one network address, and it can have shared volumes. So a pod is more or less a replacement for what you earlier have done with the entire operating system. And the next thing is a VM cluster. All your pods running on Kubernetes can be considered as being evolved from a virtual machine cluster. And then what I already mentioned, the main point you have to do is use stateless containers most of the time as cattle and pets as a database and care about the databases. Another issue is configuration management. There is not much configuration management. So you have configuration secrets all in the Kubernetes system, and there is no way of running configuration management tools inside a production container. Everything you have to do to get a container running should be installed in build time. So the containers and the pods are ephemeral. So if you have a security issue in a container, there is no way of fixing it inside the container. The entire container should be thrown away and replaced by a new one. This is the philosophy. Containers are ephemeral. You don't care about a container running for weeks. I think Google is starting 2 billion containers a week. And they don't care about what's living inside the container. They simply create a container. And if the security has fixed a library or something like this, the old container is stopped and the new container is spawned. And then everything is secure again. We have heard in the beginning that there are tools for this to scan containers in the registry for security issues. So this is the place where it should be done. There is no way of fixing containers at runtime. Okay, what I already mentioned. We have stateless and stateless. One thing is Kubernetes is completely independent from your cloud provider. You can have it in a Google Cloud, in the Amazon Cloud, on your own hardware if you implement everything. But this philosophy of using the cloud provider's services adds a little provider login. So the providers have all a little bit different services. And you can do databases self-managed, but they are this is kind of overhead. And you should always have a change to the mindset that all these things are ephemeral deployment units. Even if you run a database inside a container, the container is ephemeral. So the database should use an external storage by your cloud provider simply to store the data. And then the front end, which is tied to the load balancer, should be considered as completely stateless. There should be no state in a front end. Everything is in a business layer or in a persistence layer. In this way, you get your firewall and load balancer used by you get your firewall and load balancer replaced by the provider's firewall and load balancers. And then it doesn't matter which front ends you have. You can use internal caching, and the business logic should also be stateless, and the persistence is what you really care about it. So what we will do in the future, I hope, but it's not yet done, that you have quite an easy way of standardized deployment pipelines. So you have environments for dev, test, and production. And if you ever had a doubt if Kubernetes is usable in production, yes, we are doing it in production. And the philosophy at the moment, rolling it back through QA to dev, is just because at the moment the dev team is so big, and the interruption would be, I think, 2 sprints to teach all the devs how to use it. That at the moment we don't want to take this risk, but it's easy, and we are talking to them, and the things we have found so far will not prevent us from rolling it in QA and development. Another thing what you also should do is please avoid privileged special applications. And privileged special applications are application servers or something like the LAMP stack. The LAMP stack is running a database inside the application. This is an old and wrong way of doing it. Please separate it before you do it in your containers. Yeah. Okay, what we found this has been done. Yeah, some examples. What we found, so no application servers, the good old Java application servers should not be ported into containers because they are too heavy. What really works is Java with Spring Boot, because you can change the configuration on the command line. What was easy, Python also was easy. because Python is well packaged in the environment we found. And what was quite hard, Ruby gems, because the separation of build and deployment is not so clean at Ruby. My preferred way of doing it would be twirling Ruby, so a static application with all the gems inside, but this is something we will probably do in the future. Yeah, I already mentioned this. So the results, yeah, we have a scaled and cubified application. And on that way to that application, we had to reduce the technical debt anyway. We had to standardize our processes and APIs for management. And every application by every team turned into a pod with a single process per container. Yeah. We shrink the deployments, which is essential if you want to run it on scale, so to get it really fast. And the business value is obvious. We are faster to market. And I think simply say what's one word, what's missing. What's missing at the moment, we need a better way of container lifecycle management so that we know if we run containers which are not secure anymore. We need cleanup at this moment, so rollout of new containers. And we did not talk about database migration because these things, rolling out a stateless container can have an impact on the database running so that it triggers an implicit database migration. But this is not anything different from the standard DevOps task at this moment. Okay. Does it scale in real life? Yes, we are quite optimistic. We will see if we scale by country. And I think we did not decide if we want to run it in one cluster or a cluster by country at the moment. So this is an open decision. And yeah, if you have a special need for more information, come to our booth. So we have explained even how to run containers on your own data center. This is our example, running it on Raspberry Pis. It is possible, but the important thing is if you want to run your own Kubernetes on bare metal, then you have to look into storage, network, and firewalls. And this is something you can avoid on scale if you use a cloud provider. Okay, thank you very much. We are open to questions. Yeah.
All right. Are there any questions?
Yeah.
So I was wondering whether you want to have multiple Kubernetes clusters for different environments, because if you have something for testing or whatever, and then also the kernel having for the entire server, and that would be nice to the same production. That's what we're doing on that, right?
Could you maybe repeat the question?
Yeah. So running a mixed cluster for different production stages was your question, more or less. There is an advantage of doing this because you only need the resources you have. But I did not talk at the moment about security things. There are security issues which might be more complicated if you run production and dev on the same hardware, because at least one thing is leaking. If you use private keys in your hardware, then the Intel cache might leak it to other applications on the same hardware. And we did not deal with, there is no proof of concept for this security thing, but it also applied to virtual machines, so I expect somebody giving a proof of concept. If you don't have these issues, then you can run everything on a production cluster. One more thing is the CPU limit, and Kubernetes does not watch the I/O limit. If you have heavy I/O in production or in a test environment, it might affect the other applications. So this is not completely solved at the moment, but besides that, there is no reason of not doing this.
Right, so just a quick follow-up. I'm also more conservative, so I would definitely run our let's call it pre-production in a separate cluster. We automated the setup on AWS with Terraform. So I can only recommend automating the actual setup of the cluster as much as possible, or use something pre-built like Google. And but we are, however, as Thomas mentioned, thinking about running different, let's call it tenants within a cluster. So we are not too sure if it's just going to separate them by namespaces or use some more sophisticated SDN approach. Not sure yet.
So you mentioned Chef, and that's what you were previously using. So what have you ended up switching to when you said there was a slight gap between what Chef could do and how you're building your containers?
Mm-hmm. We still make heavily use of Chef, especially for getting things from development, QA, and let's call it like a trial environment where we test end-to-end, or integration, if you will. We were able to take some parts of our Chef configuration and put it into build time for the containers. So when we use Packer to harden our operating systems with Chef configuration that we already have. And we're right now doing the transition between Chef configurations and config maps in Kubernetes in a manual process, and we'll write a tool in the future probably to get away from that. But it's very similar. So if you have configurations for your Chef applications, you have your attributes. Most of them can translate into the parts of config maps in Kubernetes. So don't throw it away. And we will always use it for the rest that we need to manage in terms of traditional VMs, right? Our couch databases are still based on Chef automation.
Could you please elaborate? So in this new architecture where you have all the applications as pods, how does the continuous delivery pipeline look like? So what is the tool chain? And what are you using for centralized storage of container configurations? So when you need to change the configuration of some of the services, where do you do the change?
Do you want to?
At the moment, we create images and put them into our own registry. So this is a starting point of delivery pipeline. And in the future, we talk to the test department that they can automatically test things like this. So the test at the moment, because it's a telephony application, is partly not manual but orally. So they have sometimes they have to put tests into the external to detect issues in the external applications, which have to do with timeouts and noisy things like this. And if we can automate this, then we can set up a test pipeline on this. But at the moment, everything would be prepared for this, but we are not doing this actively. But in the near future, there is hope that we can do most of the tests automatically.
Yeah, and we'll probably do that until the pre-production cluster that we talked about, right? And it makes it much more easier to have things like the canary deployments, where you actually just turn a certain percentage of your services to have the new version and roll back if necessary. So it gives you much more confidence. It's not continuous live deployment, sadly, but I don't know if I really want that yet. And like we're having so much different things that we need to take care of that live deployment in this stage of the project is not really like top of the list. But like I said, you don't really need it necessarily if you do work with deployments from a Kubernetes perspective, and you can start, stop them, resume them, or roll them back. So it gives you much more confidence to put something into production than if you actually have to automate that part all by yourself in something like Chef, AWS, etc. from my perspective.
That's it, we're out of time, sorry guys.
Okay, thank you very much.
So here,
we are quite around.